Hey guys, welcome back to my YouTube channel. So today I'm going to explain to you how you should tackle the test 2 question, which consists of 3 different chapters, which are the acid and base, thermochemistry, and also chemical kinetics. So altogether we have 3 different questions. Each question will consist of 10 marks. So I'm going to go through this one by one with all of you so that you can understand more about these 3 topics. Starting with question number 1. So question number 1 is actually from the topic acid and base. So question number 1A, 4.90 gram of pure sulfuric acid was dissolved in water where the resulting total volume was 200 cm3. 20.7 cm3 of this solution was used to neutralize 10 cm3 of sodium hydroxide solution. Approximate the pH of the sodium hydroxide used in this reaction. So when you get a question like this, first and foremost that you need to do is you need to be able to write the chemical reaction or chemical equation, a balanced one, so that you can tackle this kind of problem. So first reaction is actually sulfuric acid, so H2SO4 plus you will have the sodium hydroxide and AOH. So what is the product? If you can see in the question, it states that this solution was used to neutralize. So it means that this is a neutralization process. In a neutralization process, one of the products should be water. So H2O. Okay, what is the other subproduct? So in the neutralization process, you will take the OH from your base and H from your acid. So means that you already take this one, so you will have SO4 and also Na. So if you can see here, hydrogen, you need 2 hydrogen, means that your SO4 is SO4 2 minus. So in terms of making the other product, it shall be Na2, because Na, you know that the Na is Na plus. So since your SO4 is 2 minus, because of your H, you need 2. So to balance this out, 2 and 1, so you need to have 2 sodium around here. So Na2SO4. Right. So and then you need to balance out this equation. So here at the product, you have 2 sodium, right? So you need 2 times 2 around here. So since you have times 2 around here, 2 times 1 is 2. And then plus another 2 here. So it's going to be 4. So here your hydrogen is only 2. So you need to times another 2. So you have 4 hydrogen at the product. You have 4 hydrogen at the reactant. 1 SO4, 1 SO4, 2 sodium and 2 sodium. So this is what we consider as the balanced equation for this particular reaction. Alright. So what is the next step? So the next step that you need to do is you need to find the number of mole for H2SO4. So we are going to calculate number of mole for H2SO4. Alright, the number of mole is equivalent to mass over RMM. Okay, so what is the mass of your H2SO4? So here, pure sulfuric acid, the mass is 4.90. So 4.90, that is the mass. So and then the RMM, you should use this table given to you, right? So remember, when you use this table, we have the symbol, atomic number and atomic mass. Since we are calculating the RMM, you need to use the atomic mass. So you go and find the atomic masses for the hydrogen, sulfur and also oxygen, right? So you should get the RMM for H2SO4 is equivalent to 98.0734. Therefore, you will get the number of mole for H2SO4 is equivalent to 0.0499 mole. So this is the number of mole for H2SO4. Okay, since we already calculated the number of mole for sulfuric acid, then we need to look back at the question here. So it states here that this acid is being dissolved until the resulting volume is 200 centimeter cube. So from here we can grab or we can calculate the molarity. So molarity is equivalent to mole over liter. So the number of mole is the one that we have calculated just now. So the number of mole is equivalent to 0.0499 mole. This is the one that we have calculated. So 0.0499 divided by, okay, what is the volume, right? Here, the volume until the total volume is 200 centimeter cube. So 200 centimeter cube, you need to convert it to liter. So you divide it by 1000. So you should get the molarity of sulfuric acid is equivalent to 0.24995 molar. Alright, and then this is not all. Okay, look again. In the question it states that only 20.7 centimeter cube of this solution was used. So we only use 20.7 centimeter cube. So since we only use 20.7 centimeter cube, so you need to find the number of mole again. So molarity equivalent to mole over liter, right? So we only use 20.7 centimeter cube, right? So 20.7 centimeter cube, you need to convert it to liter. So you need to divide by 1000. So the number of mole of H2SO4 that you use in the reaction is actually just 5.1739 times 10 to the power of negative 3. Okay, this is the number of mole of sodium hydroxide that you use. So again, we are going to refer to the equation that you have made. Okay, see from the equation. So for each mole of H2SO4, you will need 2 mole of sodium hydroxide. So from there, you can write 1 mole H2SO4. You will need 2 mole of NaOH, right? So since you have this much H2SO4, so you will write 5.1739 times 10 to the power of negative 3 equivalent to how much you need, right? So 2 times this value, the same value, 5.1739 times 10 to the power of negative 3. Okay, we have not finished yet, because if you look at the question, you were asked to approximate the pH of the sodium hydroxide used. So since you already know how much or the number of mole of sodium hydroxide that is being used inside this particular reaction, so from there you can actually calculate the molarity. So again, molarity is equivalent to mole over liter, right? So you know the number of mole of the sodium hydroxide that you have used, which is 0.0104 mole of sodium hydroxide. And then in the question, it is stated there that this solution is used to neutralize 10 centimeter cubes. So the sodium hydroxide that is being used inside this particular reaction is 10 centimeter cube. So 10 centimeter cube, you need to divide by 1000 because you want to convert it to liter. So you should get the molarity of the sodium hydroxide is 1.04 molar. Okay. So, but still, this is not the pH. So, how are you going to calculate the pH? So, next thing that you need to recall is NaOH. So, is the NaOH a strong base? Yes, right? So, it means that the concentration of NaOH should be equivalent to the concentration of OH minus. So, this one should be the concentration of the OH minus, but you were asked to calculate the pH. So before you can calculate the pH, you need to calculate the pOH because this is not an acid, this is a base. So pOH is equivalent to negative log concentration of OH minus. So since that you already know the concentration of the OH minus, so negative log 1.04. So you just need to press your calculator. Negative log 1.04. You should get negative 0.0170. Okay. So this is the pOH. You were asked to calculate the pH. So pH plus pOH equivalent to 14. So your pH is 14 minus your pOH. This is your pOH, right? So your pOH is negative 0.0170. So you will get your pH equivalent to 14.017.